Good morning. This is the beginning of Unit 2. We're going to graph rational functions. So I have a rational function on the screen. Really should say like y equals. So y equals x over x squared minus x minus 2. And so in this first slide, I want to talk to you guys about vertical asymptotes and domain. So vertical asymptotes occur anytime that the denominator is equal to 0, because you can't do something divided by 0. All right, so let's put that down. Denominator equals 0. So what we want to do is factor and figure out where does the denominator equal 0. So if I split this into two sets of factors, I'll get x and x, and then minus 2, positive 1. And so if I multiply that out, I should get x squared minus x minus 2. So those are the two factors of the denominator. And if those are the factors of the denominator, then to make the denominator equal to 0, this first parentheses would say that x would have to equal 2. It's 2 minus 2 is 0. The second one would say x equals negative 1. And so those are actually my vertical asymptotes. Rewrite the equation of a vertical line using x equals. And so my equations of my vertical asymptotes are x equals 2 and x equals negative 1. That means the domain is going to be all real numbers except for 2 and negative 1. And so you might use interval notation. You may have done that before. So if I use interval notation, I would say negative infinity to negative 1, from negative 1 to 2, and from 2 to infinity. You could also say the domain is all real numbers except negative 1 and 2. So that's how I would do vertical asymptotes and domain. And then if I want to graph, like what does that look like? Give myself a graph here. I would graph some vertical dashed lines through negative 1 and through positive 2. And that would be the start of my graph. If I have a factor on top and bottom that cancels, that would be considered a hole. And we'll take a look at that first in a second as well. So if we have a hole in the graph, it'll look like this, almost the exact same function, but this time I have an x plus 1 on top. And so when I take the bottom of the denominator, so it's a different function, but just slightly. We had an x, now we have an x plus 1 on top. When I factor the denominator, I can see that these x plus 1 factors will cancel. And so this equation is going to be almost equivalent to 1 over x minus 2. So we're still going to have an asymptote, vertical asymptote, at x equals 2. But this time we have a hole in the graph at x equals negative 1. And so what happens with that is that instead of having a vertical line at both of the locations we had before, now we're going to have a vertical line at just one of them, x equals negative 1. And if I take x equals, at x equals 2, we said the vertical asymptote was at 2. And at x equals negative 1, there's a hole. If I plug in negative 1 into this equation, it's going to be 1 over negative 1 minus 2. So that's negative 1/3. So my hole is at negative 1 comma negative 1/3. And so as this graph is graphed, there's going to be a hole there. So it's basically a discontinuity. You draw the curve, but you put this hole on your curve to show that at this one point, it is still a domain issue. The domain of this function is the same as the domain of the previous function. So my domain is still going to be negative infinity to negative 1. Negative 1 to 2, and 2 to infinity. So it still doesn't include negative 1. But the difference between a vertical asymptote and a hole is whether or not that factor cancels.